FlippedHarber for Precalculus. In this video we'll be covering section 6.1, Trigonometric Identities. The objective for this lesson is to learn how to establish identities. The outline for this video, we'll talk about what the heck an identity is. We'll talk about some identities that you already know, namely the quotient, reciprocal, Pythagorean, and even-odd identities, and we'll talk about a process for how to establish an identity. Now, really, an identity is simply a statement that says two functions are true for every value of the variable. So no matter what we plug in for x, or quite often we'll be using theta, the two functions are always equal. If an equation is not an identity, it's referred to as a conditional statement. So really the difference would be, like we see here on the screen, the square root of x is equal to x to the 1/2 power. That is always true. No matter what we plug in for x, the square root is equal to a 1/2 power. A conditional statement is an equation that is basically sometimes true. It depends on what we plug in for the variable. So x squared equals 2x is true if we plug in the right numbers. If we plug in 0, it's true. If we plug in 2, it's true. But it's not true for every single value for x. So it's not an identity. Now, your job is going to be taking some identities that are known to be true and use them to prove other identities. The identities that you're proving are true. You have to kind of have faith there. Don't just say, oh, you know what, I can't seem to prove this, so it must not be true. Now, let's take a look at some identities that you've seen before. Okay, the first one's the quotient identities. The tangent theta is equal to the sine theta over the cosine theta. Now, these are identities, ones that you're not going to be asked to prove, they're ones that you're going to be asked to use. Now, similarly, the cotangent of theta is equal to the cosine of theta divided by the sine theta. So basically, these give us ways to substitute into these identities that we're trying to prove. Here's some more identities that you're aware of. The reciprocal identities. The cosecant of theta is equal to 1 divided by the sine theta. Secant theta is 1 over the cosine theta, and the cotangent theta is equal to 1 divided by the tangent theta. Again, this gives us more things that we can substitute in to establish these identities. Here's some more, ones that you need to be very familiar with and are very popular whenever you see a square on a trig function. These again are called the Pythagorean identities because they're based off of the Pythagorean theorem. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. Well, that comes to us by dividing the top identity by cosine squared. The bottom one, 1 plus cotangent squared theta equals cosecant squared theta. Well, we take our top Pythagorean identity and divide everything by sine squared. Now we have the even-odd identities. The sine and the tangent are odd functions. That means that the sine of negative theta is equal to the negative sine theta. Same with the tangent. Cosine is an even function. That negative basically just goes away. The cosine of negative theta is equal to the cosine theta. And then similarly for their quotients. Now, establishing an identity means that we're trying to prove that it's true. Now, we're going to take the identities that we've been looking at, and we're going to add to this list later in the chapter, but we're going to be working with just these given ones that I gave you previously in the video. And we're going to be establishing some other identities. Now, really that means that we're going to be trying to prove that they're true. Now, we'll take a look at an easy one. The secant of theta times the sine theta is equal to tangent theta, and yes, they get more difficult than that. Our first process, the first thing that you need to try to do when establishing these identities is to always try to work with the more complicated side. Now, in this book, and really most books that I've seen, you're almost always working with the left side. Now, don't take that as carved in stone. Sometimes you work with the right side. I can't say that you always work with the left side, but I can tell you it's in your best interest to always work with the more complicated side. Now, Quite often it's useful to rewrite sums or differences of quotients as a single quotient. Basically, that's just a fancy way of saying combine fractions if you can. Getting them down to one fraction is usually a really good idea. Now, a good place to start when you're stuck is to rewrite everything in terms of sine and cosine. Now, I'm not going to say that you always do this, but it's a good place to start. So if I take that left side and I rewrite that secant in terms of sine or cosine, that means I'm going to be using a reciprocal identity to do that. Now, you want to keep your goal in mind. If you've got some squares on the other side of the equation, then that means that you don't want to get rid of all of your squares on the side that you're working on. If you've got some things added together, well, maybe you want to leave that addition in the middle and try to kind of work around it. So keep your goal in mind while you're doing this. Now, one thing you do not get to do, you do not multiply or divide or add or subtract things across that equal sign. You are working with only one side of the identity that you're trying to establish. The reason that you don't do that is because these identities are set up to always be true. If you multiply by something, or more importantly, if you divide by something, you might be actually dividing by something that you can't divide by, which of course would be 0. So you don't get to move things from one side to the other. Now, you may think, oh, what's the harm? Well, you don't get to do it. If you do it on a test, you're going to lose a point every time you do that. Every time you move things from one side of the equal sign to the other side, you're going to lose a point. Now, doing that and losing 1 point is probably better than not doing the problem at all and losing all the points. So you're not supposed to do it. I don't want you to do it. I don't want to encourage you to do it. But push comes to shove on a test, you do it, you're going to lose a point, which is better than losing all the points. Alright, so let's go ahead and talk about how to establish this identity. So if I follow my guide that says I should choose the more complicated side, that would be the left side here. Obviously, 2 trig functions multiplied together is more complicated than 1. So now my next step would be, well, how do I change that? Well, let's go ahead and use that quotient identity that the secant of theta is equal to 1 over the cosine theta. Now, this is not like a geometric proof. You don't need to write why you're doing anything. Just make sure that you're using your identities properly. I don't need a reason column over here. This isn't a geometric proof. Now, we go ahead and combine the fractions, or really just multiply that sine theta onto the top, and we have sine theta over cosine theta equals tangent theta. Now, basically, I can stop here because I've created an established identity. I can stop here, or I can take it the next step and just say that the left side is tangent theta, so I have tangent theta equals tangent theta. But if you get it down to a point where it is an established identity, that's good enough for me. You can stop there. Some professors will make you take it that step further so that you have tangent theta equals tangent theta. Okay, let's try a little bit harder for one. Now, I notice some squares in here, so right away I am thinking Pythagorean identity. Now, this Pythagorean identity can go both ways. Remember that. I don't necessarily have to have sine squared theta plus cosine squared theta and replace that with 1. I could replace 1 with sine squared theta plus cosine squared theta. But let's go ahead and choose to work on the left side, and let's go ahead and change that cosecant into a 1 over sine. So I'm following my method here, replacing anything that's not a sine or a cosine with sines and cosines. Now, I multiply sine theta by 1 over sine theta, I get 1. Now, I know you're probably dying to just add that cosine squared theta over to the other side. You've got 1 equals sine squared theta plus cosine squared theta. Now, that's true. Doing that is true, but I'm not allowed to move things across that equal sign. So what I'm going to do instead is what I talked about earlier. I kind of hinted. I can replace that 1 with sine squared theta plus cosine squared theta. Now, how do you know when to do this? It's experience. 585 years has led me to make some really great decisions when establishing identities. But it's just something you've got to get used to. So now I've got a plus cosine squared theta minus cosine squared theta. Shaboom, they cancel out. I've got sine squared theta equals sine squared theta. That identity has now been established. It's been proven to be true. Okay, so that's it for my examples. This is really one of those things that you need to just start working on. So, start working on them. I'll see you in class, and I'll see you online.